Hello everyone. I am Mrs. Usha Jadhav, Assistant Professor, D.Y. Patil College of Engineering, Akkudi. Welcome to this International Web FDP on Environment and Sustainability. My topic is what is the role of semiconductor industry for environment and sustainability. Previously, I have given the two different videos on the same topic. So this is the week 4 video. The outline of this week 4 video is this one. So before telling this outline, in the week 1, as we have discussed that the semiconductor industry always play a vital role in a society which is providing a microelectronic components like chips or the integrated circuits that are used in wide variety of electronic applications, starting from the different types of bulbs, smartwatches, mobile phones and the portable devices. So this rapid increase of the production of chips is responsible for considerable effects on the environment during the various phases of its life cycle. So in the week 1, we have discussed that the use of semiconductor devices and chips. Also we have discussed the different environmental indicators which includes eutrophication, water stress and smog. Also we have discussed what is the environmental impact of microelectronic chips. Then in week 2 we have discussed the different ISO standards like ISO 14031 and 1999 and along its versions as 14000, 14041, 14042, as well as it involves the various agencies like WEEE, ROHS and so on. Also in a week 2, we have discussed what are the different general phases of microelectronic component life cycle which plays a vital role for providing the product from manufacturing to the end of the that is to the application oriented consumer hand. And also we have discussed what is the expert ranking of these environmental concerns in manufacturing plant and in design center, and we have seen the impact of these chips or the integrated circuits on the various like carbon CO2 emission, or we can say on ozone layer depletion and so on. So in the week 4, this is the outline of week 4 which is going to summarize the different standards and its purpose. The outcome of this using the higher order thinking words. Also it includes how to do the carbon footprint calculation and shows the results of your various case studies as CO2 emission, and will discuss sustainable ways to reduce the carbon footprint of semiconductor devices, and will conclude. So by considering the various ISO standards or the IEEE standards related with this environment and sustainability for a semiconductor chip, which is the main standard is nothing but ISO 14031, that is 1999, which is nothing but used for an environmental performance evaluation. So this EPE process will facilitate the management decisions regarding an organization's environmental performance by selecting the indicators. We can collecting and analyzing the data, assessing information against environmental performance criteria, reporting and communicating, and periodically reviewing and improving this process. So similarly, this ISO 14040, ISO 14041, ISO 14042 and ISO 14043, which is also used for this environmental performance evaluation but through the life cycle assessment. And this life cycle assessment process is a systematic process which is phased approach and consists of 4 basic components like goal definition and scoping, and especially life cycle inventory analysis, which is nothing but an LCI, impact assessment and its interpretation. So the impact assessment and interpretations of this LCI will vary starting from 040, 041, 042 to 043. Also, this waste of electrical and electronic component equipment agency, such as everyone knows that the various electronic equipments like computers, TV sets, fridges, cell phones is one of the fastest growing waste streams in the electronic area. But now the waste which is generating, it is more than 12 million tons of wastage it is generating. So this, the aim of this or the purpose of this WEEE is to enhance the resource efficiency through improvement of collection, treatment and recycling of electronics. The reduction of hazardous substances, that is ROHS, is used to reduce the environmental effect and health impact of electronics. The legislations, the primary purpose of this ROHS is to make electronic manufacturing safer at every stage of an electronic device's life. Similarly, the fifth agency, that is eco-design of energy using products, is to improve the energy efficiency of energy using products. It thus contributes towards reaching the European Union's targets for climate protection. So the main aim of UOP is the climate protection, and which will improve the energy efficiency of energy using products, that is UOPs. So these are the various standards with its purpose are used especially to find out or to analyze the data and control on the different hazardous effects on an environment. So you can observe here what is basically the outcome of these various standards. Now with respect to this, the main action plan of these various standards is to plan, followed by this to do, and then act. So based on this environmental performance evaluation, first it will plan, followed by it will give the various types of the indicators, where these indicators will assess you the various parameters, followed by we are going to collect the data, and this data once we'll collect the data, we will apply some processings like production, foaming, photolithography, and we can analyze the data by using the various kinds of softwares, like by using the Mentor Graphics is the high-end tool used for analyzing that is a transistor performance, as well as, and as this analysis of data is based on the various application of the voltage we are applying to this the transistor or the supply we are providing, then we are assigning and we are assessing that the results and the information, and then we are generating the report and communicating that report. So once this report is generated and it is communicated through the product, now the next important step is we can review and improve, means we can act upon it and we can improve the performance of the devices so as to it will reduce the environmental impacts which is negatively happening right now. Now you can observe from this figure how there is a carbon dioxide emission in the 4 case studies, especially given by the Villard 2019. There are 4 steps will occur from the starting of the manufacturing to the end of the product. The life cycle includes 4 stages. First stage is your manufacturing, second stage is your transport, third stage is use, and fifth stage is your end of life. So by considering this stages, you can observe here in this figure for a power management for telecommunication is very important one. So this for the power management in telecommunication, 39% is manufacturing, in a manufacturing stage, 39% the power will affect. Then during the transport it is 3%. Then especially this is during the use there is a 58% and 0 during the end of life. But security card for television, as everyone knows that we are having the EPBX for television. So for this we are using especially a security card for this your television, which includes the integrated chip. So for this we can observe during manufacturing of this card 42% this CO2 emission takes place, while 24% during transport and 34% during its use of your device. Similarly, microcontrollers which is used in the dashboard of our cars, in which during manufacturing of this microcontroller 69% is your the CO2 emission takes place, while your 24% is during its use. Similarly, as you know that there are various types of memories are used in your the laptops, your mobile phones and the portable devices. So you can observe here during manufacturing of these various types of memories, starting from your random access memory to read memory, during manufacturing 89% of CO2 emission takes place, while during transport it is 6%, means when it is performing its usage. So like this is the CO2 emission takes place during the various stages of your the microelectronic industry. Now let us see how the carbon footprint calculation for a case study is going to consider, in which we are going to consider a mobile phone MIA2, where this MIA2 have a battery life of 7.5 hours with mobile data on, and it is 8 to 9 hours without mobile data is on. It uses a lithium type C battery with 3.5 mm. So its voltage is 5 volt with 2 ampere charging, and normal the 10 watt charger power consumption is 10 watt. The average charging time is 1 hour 20 minutes, that is 80 minutes, and approximately 1.33 hours is the charging time. If suppose we have a mobile phone with 4 GB RAM and 64 GB storage, and the emission factor, that is nothing but the number of hours of phone use through the factor 57 gram, that is 57 gram of your the CO2 footprint per minute use. So by considering this, so for this carbon footprint calculation, the hours multiplied by days multiplied by the watts, it is going to use divided by 1000 will give you the kilowatt hour, and then kilowatt hour multiplied by the emission factor will give the greenhouse gas emission or the carbon footprint in kg CO2. So emission factor during the charging is 57 gram, during calling 15.83 gram, during Bluetooth it is 6.33 gram, during application using it is 66, especially the video games we are using, that is 66.5 gram, and then texting, while texting the message to the various apps, this is 171 gram. So by considering this carbon footprint calculation for the various application, you can observe that the charging will take a greenhouse gas emission of 1.0082 for 1.33 hour, that is for 80 minutes. Similarly, charging plus calling for 80 minutes will take 0.2799. For Bluetooth it is 0.5453, where application using it is 1.1762, means as it is using the phone with having some graphical context, and during the texting it uses 2.2743. So this is the carbon calculations or the carbon footprint. Now for a sustainable ways to reduce the carbon footprint of semiconductor devices is nothing but we have to unplug that is your devices when it is fully charged. Then always we want to drive a less but use a bicycle. Then don't buy a fast fashionable devices, which includes the electronic integrated circuits. Line dry your clothes, switch to sustainable clean energy using renewable sources. So this is the main important sustainability to improve your the integrated circuits. So these are the various references included here. Thank you very much.